Welcome to the Blind Tinkerer's Workshop. Yes, I know, electronic video. I printed out George Kostapi's instructions on where to solder that lead, and it is not on the solder blob like I thought it would. I experimented. I got my power supply set at 12 volts and the current way down. And when I touch the lead onto the solder blob where I thought it would go, and I can hear my power supply relay click, even though, so in other words, it's a short. So, according to George, I'm going to try to get into this close here with this camera. I'm using the Play Touch. It's supposed to go between the little capacitor C2 and the electrolytic on where he says that oblong trace has been pulled out. Well, I can't make any connection there because it's gone. I can't even see to thread that wire through. I need so much magnification, I just cannot see it at all. It took me a long time to get these wires to go in for the speaker into these screw terminals here. They kept coming out, and I had to crank them down so hard that I twisted the green block. You can see it's moved a little bit. I straightened it out a little bit. I can't work with this stuff. I'm sorry, guys. You know, it's easier for you to say you got excellent eyesight. I'm half blind here. I cannot see to get that wire in. It's like threading a needle. So, I hate to say it, but I'm not going to be able to use this thing because I can't get it to come on at all. I'm taking and probing around with the clip lead, the positive lead, onto the areas where he said. Now, if I was to go underneath the board here, I'll turn this over. And on the bottom of the electrolytic, I think these two tits right here, to the left is the IC, the output IC. And then to the right, there's a row of connectors. And right there, in the middle of the screen, is two tits, and I think that's the electrolytic. But it's so small that if I try to solder on that, I'm going to bridge everything over. You guys on the video have seen traces on top. I cannot see them. I'm looking at the same video that you guys noticed on the last video I put up on the, I believe it was the HD one. So, I don't see traces. In other words, I don't see a trace going to the positive terminal. So I'm experimenting and I'm sticking the probe in wherever I can and watching my power supply. And that's all I can do, and so far I got nothing out of it. Of course, the audio output is not connected, but I should still hear a click or something when I energize this. And I only have one speaker on. I have test speakers in the shop here. Up there. So that's not a problem. I can hook it to them. I just got to bring the wires out and down to here, but it's just as easy to put this on. This is one of the speakers that I took out of Dorkel. So, I hate to say it. I appreciate it, George, but I'm just not going to be able to work with this stuff. Time and time again, you know, I'm almost totally blind. You might as well say that. You know, I'm lucky I can see it all. I cannot work with this stuff. I cannot see. I have to hold a magnifying glass. You know, I tried everything to do that. I need 5 hands. You know, the phone will bring everything up, but I cannot work underneath a video. I cannot get coordinated. So, anyways, I can't. What I'm going to have to do, you know, as much as I appreciate this, George, and I can't keep having somebody do things for me. You know, I can send this out to somebody, maybe to be willing to solder this into the proper place. I'm going to look and see if I can find an old school, a 1970 12-volt transistor amplifier that's probably maybe as big as this box here. You know, maybe as big as this. Something I can see, something with terminals on it, that or a place to solder. I need something large. Yes, it's going to take up room in Dorkel. I can't work with these small things. The only way I could work with this, it would have to have wires coming out like this. But it's, you know, I can't even work with these things here, putting connectors on. I tighten them up and they pull out. They just don't work right. I cannot see. It's like threading a needle, literally like threading a needle. I just can't see that. And this is nothing compared to trying to get this wire back in that hole, because I need so much magnification. And I'm sorry I'm not complaining. I'm aggravated with bad eyesight. I cannot work with this stuff. And when I saw this, I says, oh my God, how am I supposed to work with this thing? You know, I appreciate it. Please don't get me wrong, George, or anybody else that send me stuff like this. I just cannot see it. So I need old school amplifier, transistorized, of course. Something with an output transformer, probably 10 watts, and I may not be able to get it without getting something humongous. I cannot see this. And the only way I'd be able to deal with this, it would have to be custom built with leads coming out and strain reliefs so that they don't get broken off. And then I can work with the ends of the wires and connect them up inside Dorkel. All right, so I'm not doing any more with this. I gave it a good try. I followed all the instructions. Now, I was half tempted to solder right here. Let me show you. I was half tempted. That C2, that little surface mount, I was tempted to solder right to that damn thing, because the traces pulled out below here. But I didn't. I resisted the temptation. I cannot work with this stuff, guys. Please, you know. So I appreciate it. Again, I'm repeating myself, but I'm destroying this thing. Trying to get this in there. I'm twisting the hell out of this. Tightening these screws because this thing, they keep popping out. And these leads for this speaker here is already tinned and nice and, you know, nice and smooth. They should go in there. It's probably because I can't see and I'm not pushing them all the way in. I just cannot see this. So this thing is way too small for me to connect those wires back up. So that's the end of this this trial. I will be looking for an old school 70s or 80s transistor, 12-volt transistor amplifier. It could be stereo, it could be mono, because I can use one channel to connect to Dorkel speakers, and the second channel I could use to run the relay to try to make the voice activated mouth, if that's possible. So stereo would probably be okay, but I would need probably, I guess 10 watts, I don't know. So anyways, that's it on this one. I can't deal with this, it's too small. Okay, I made some tests on this, including one of my other viewers' suggestion, and connected up the SCR back up on here and ran it on the Variac, and the SCR kept firing and firing and firing, going off, on and off, and running warm. This was cold. The heat sink on the 6388 was cold. And all I was getting about is 1.5 volts out of this thing. So I disconnected it again. Now, as of last night, I was getting exactly 13.81 volts out of this. And I ran a window motor, and the extra one, the one that makes the noise, on this, rock solid 13.81 volts. I don't know if it's going to still be putting out. All I got is the meter on here now, Let's put it on. There it is. 13.8 volts. That's with the SCR off. Now, I spoke to Jim about this again last night on the phone. I was talking to him for quite a while. That poor guy, he doesn't get a rest from me, I'll tell you. And he says this is not a voltage regulator. It's there to clamp in case the voltage goes too high. What happened was this thing fired off and shorted the whole output. Okay? Leave it off. We're getting 13.81 volts right out of it right now. There it is, right there on my meter. I don't know if you can see that with the reflection here. Direct. 100 and, let's see, 118 volts, 117 volts going into the power supply right now. Not through the variac. So we got tremendous. This is ice cold. I don't know what was happening before, but we leave this SCR off. It's a crowbar circuit. And the circuit that Jim Asbell designed and built for me, I got to get a 15 volt Zener. We're going to put an external 8 amp. It's going to be an 8 amp fuse coming out of here with an SCR, which I have right here, a 15 volt Zener and a few resistors. I've got this circuit. We're going to mount it in a box on the outside of this. We're not going to put it on the inside or anything like that. So that way, if I get a 2-meter ham radio in the future, 8 amps, it shouldn't take more than that. That'll be protected. That will have an SCR in case the voltage goes up too high, beyond 15 volts. It will clamp. So we don't need this. And of course, naturally, it'll be limited to an 8 amp supply. I would imagine I can increase the fuse to a 10 amp if I choose to, or even a 12 amp or whatever, but I think 8 amps is fine. So this is working. As you can see, there it is right there. Now I made a test by putting a load on this of this motor here. This is the first motor. This thing here screamed like a banshee. It stalled out because of the bearings. This is the first one I was going to use, and I'm taking screws and washers off of that when I made the other one up. This stalled out either direction, and when it stalled out, I was monitoring the voltage. I did all this off the camera last night. Steady, 13.81 volts. It did not drop at all. Although the wires got very warm. Not these wires, but the clips that I had on here got very warm when it stalled out. So I would imagine that when this thing stalls out, it probably stalls out at about 10 or maybe 12 amps, I'm guessing, because I did not have an amp meter on it. That's another thing I would like to be able to do on this power supply, but I'd have to have some way to cut the metal without making a mess. This is heavy panel. I'd like to have a voltmeter over here and an amp meter. It's most important to monitor the output voltage to see that it doesn't shoot up too high. Digital meter, I guess, would be all right. And an amp meter to see how much current you're drawing. But there it is. The 2N6388 heatsink is ice cold. Of course, the only load on this thing is there's no load at all. There is, what Jim said here, there is a resistor right here, 2 watt, that is warm. It goes across the output, and what Jim told me is it's essentially across the output. I think it's a 2,000 ohm resistor, but I'm not sure, or a 200 ohm. Don't quote me on that. I'm trying to go from memory, and my memory's not worth the powder to blow it to hell sometimes. So this is warm. This is quite warm. Okay? It's because I guess there's got to be a little bit of a load on it, so this is on it all the time. Okay, I'm going to connect Screaming Mimi up here. It might lock up. Of course these are thin leads, and these got warm a little bit when this motor stalled. Hear it? Now look at the voltage. Ice cold. And the leads are warm. Okay? Joe, Mary Ann's husband, said to file a tit off of this, and I did that last night, but I guess I got to file it all the way off, the whole thing out of here, I don't know, and put some oil in the end bearing, but I'm not going to mess with this motor. I got the other one that Owen sent me that's now in Dorkel. So, this just proves that I have a steady output of 13.81, 13.82. You can see a tiny bit of variation there, which I guess is perfectly normal. But if you connect this thing up, this SCR got very, very, very warm, because I made the test that John Sweet told me to do. I did not answer the comment yet. I haven't had a chance to. And I'm getting overwhelmed by comments anyways, and especially with John, because he, you know, he disagrees with just about everything I do. And he means well. You know, I'm not biting your head off, John. I'm just, like you said in the comment, I'm just saying, you know, this is not a voltage regulator, okay? So, I'm going from good advice from James Asbell. And this is just a crowbar circuit. And it's possible maybe that the SCR is bad. When I had this connected up, I had it running to the variac. I had 45 volts coming into this. And this amp meter was jumping all over like this. Every time that SCR fired, it was going like this. And I was getting about 1.5 volts out of here. When I took this thing off, after I turned it off and did that, I have my 13.8 volts. So the problem is in either this SCR or its circuitry. There's a lot of power supplies that don't use the crowbar circuit. So we're not using it, and we're going to use that external circuit that Jim gave me a schematic to. But one thing at a time. This is kind of like a secondary project. More importantly, the motor reversing circuit. This is a schematic I got off of the internet. I've been spending a lot of time on that, and that's why I haven't had a chance to not only answer people's comments or try the amplifier that George sent me until this morning, because I've been busy with this stuff. And this is a single relay, of which I have one left. And I have the other two. These were sent to me by Steve O. I haven't heard from him in a while, but he sent me these, I believe it was last year. And two of these are in the Dorkel body. One is for the left turn and one is for the right. This circuit here uses one relay. And I marked the terminal numbers on that to correspond to this relay. I experimented with this yesterday, but I had so many clip leads, and I must have made a mistake somewhere because the leads were running warm. But this would not work in my circuit for the arm motor, and I want to tell you why. When this relay coil is energized, these two flippers, I call them flippers, I don't know really what to call them, the flapper inside that switches over from one contact to the other, okay? I guess you call them switch contacts, okay? Right now it's in the rest position, okay? Which means you've got 12 volts feeding this coil. So if you de-energize this coil, of course, naturally this is the normally closed position right here, okay? So what I would have to do is to, at the same time I'm feeding voltage here, I have to stop feeding voltage here, because this voltage here, the plus and minus, is going to keep this motor going. So we can't have that. We need one button operation by the remote control, the wireless remote, on channel 3 of the A, B, and C. Channel C would be the arm motor, and channel D could then be the mouth trigger if I go that way, or the long thin wire for the mouth solenoid. So when I push the button on the remote to lift his arm, it's going to energize this coil, and naturally there's 12 volts going here. When I release that button, this coil will be de-energized. However, this must also be de-energized because it's in the rest position, and the motor will just keep on going. Limit A and limit B, I haven't figured out how to put limit switches in there. Mechanically, I don't think I can do that. There's just not enough room. So again, I'm going to have to watch where this arm goes. So the circuit I need is basically on the wireless remote, you hold the button down, the arm goes up. Let go of the button. I want the arm to stay in one position. We're holding that 13.82. All right. When I let go of the button, when I push it again rather, the arm will either go back up or it'll go down. And I have to figure out how to make the reversing circuit work. Remember, all this has to work with the wireless one-button operation. I don't think that's possible. So what I'm going to do is try to build a sequencer, mechanical sequencer, similar to an accumulator on a jukebox. The motor goes around, hits a bunch of contacts. But instead of hitting a bunch of contacts, the disc will go around and hit a micro switch at a predetermined time, at which time the arm is going up, and then I have to time it so that it'll hit the next micro switch and change direction of the motor. So essentially it replaces a relay. The sequencer motor could be a simple geared down 12 volt motor, which will get the same 12 volts that the arm motor would be getting. This is something that's in the back of my gray matter, and I can work with large stuff. I just have problems working with tiny things. So everything I do has got to be done on a large scale. And I know I'm talking and talking and talking and talking. I'm good at that. Not much good at anything else but talking. So I got that idea in my head, and I got to try to find two normally closed micro switches with a little lever with a little, like a little roller on the end like. I had two of them, and I think when I got rid of the Dorkel original assembly, I threw it at a ham auction and got rid of the whole thing. The original motor reversing circuit safety switches from Solder Shack, John, formerly of Solder Shack of the UK, he's no longer around. And I got rid of that whole thing because it was way too small. I should have saved the micro switches from it. So that's not a problem. We can probably pick those up on eBay. But these are things I'm working on. So I'm working on this. So the Dorkel arm motor may go and just be sitting the way it is now, unwired. And I'm going to look for an old school amplifier, solid state, 12 volt amplifier, no bigger than this. This thing is about, I would say 5 inches long. So no bigger than this box. Something I can see, something I can work, and something, hopefully it's all together, and all I got to do is put the wires into it. That's it. I did give it a try, and the transformer's warm. Like Jim Asbell said, that's a hunk of iron to magnetize. So it's drawing about an amp just sitting there, you know. So let's turn this off. We're 13.82 volts. Turn it off. It takes a while to drop. It's off now. It's amazing. Yep, there it goes. There it goes. So we're getting 13.8 volts, which is the output that this is supposed to put out. Rectifiers are ice cold because basically there's virtually no load on this thing at all. So I honestly believe, and this heatsink is ice cold. Yes, the last time I showed this was running very warm. Something happened when I took and put a clip lead back onto here and connected this SCR back up like John Speeder said to do. It caused this thing to go crazy and only output about a 1.3, 1.9 volts. And it was drawing an awful lot of current off the line at 45 and 50 volts. I didn't even go up to 71 volts. So taking this off, this thing's working A1 now. Perfect. All right. That's it, folks. So I got to do a little more filing on this. I'm not too worried about this thing because I got the other motor anyways. And I'll try to put some oil in there like Joe said to do. But I filed the whole thing almost flat, the little tit that was on there, and I don't see any hole there yet where I can put oil in. But that's in the future. So I've been busy doing a lot of different things here. So today's a good day to work in the shop. I will be on the computer trying to find some sort of a motor reversing circuit to try to avoid building that mechanical sequencer. And all that thing is going to do is the disc is going to go around, hit one micro switch, reverse the motor, come around 180 degrees, hit the other micro switch, reverse the polarity. That's all it's going to do is be reversing the polarity. And all that has to happen before the arm reaches the maximum travel. In other words, when the arm is almost all the way up, the polarity must be reversed. If I don't get the timing right, there's going to be big problems because it's going to come to the limit. And if the motor has not changed direction by that time, there's going to be big problems in Afflocket City. Thanks for watching, folks. Sorry for the long rant on the amplifier, but I gave it a try, George. I really did. And please don't get me wrong. I do appreciate it. And I mostly appreciate these transistors, that took good care of this power supply. It is now working. So we'll leave this off to the side and move on to other things. And we'll work with the external circuit at another time. Until then, keep dry, everybody.